Hi, I'm Jeff Russell, Assistant Professor of Dance Science at UCI. So I'm in the dance department, but in the middle of the School of the Arts, I'm a scientist, and we're doing some exciting things that bridge between arts and sciences. This is the Musculoskeletal Dance Science Research Laboratory, and we're doing some real interesting work on motion capture and how biomechanics affects the musculoskeletal demands on dancers, and actually we're starting to work with some musicians as well. So quite an interesting thing, and just want to have an opportunity to show you a bit of it today. Great. So what we're able to do is we have 6 different cameras, and the cameras will pick up the reflective balls. And so if you see on Monica, just point out the balls that are there on your hips. You see 2 on her knees, and then down at her ankles and her toes. And then she's got 2 on her back as well. And so as she moves, so just do your movement pattern, Monica. As she moves, the cameras are tracking those balls because the cameras have either a visible red or an infrared wavelength, and it reflects off the balls, and the camera's able to see what the balls are doing. And consequently, when that happens, we get a picture 6 different ways of the camera angles. And then all of those markers are then constructed in 3 dimensions into a model that will help us to assess the biomechanics of the motion. So on the screen here, you can see that as she's moving, it looks like just a mass of markers going all around every which way, and the different colors mean different camera angles. But the software of the computer will then take all this information, put it together, and form a model that will help us to look at forces, ranges of motion, accelerations, different kinds of things that we need to assess motion. And then if we can compare injured dancers versus uninjured dancers, injured instrumentalists versus uninjured instrumentalists, less skilled dancers versus more skilled dancers, and we learn a lot about motion, but we also are learning a lot about the demands on the body of the different activities that we're filming. Now we'll show you Yvonne with her violin, and she'll go into the capture space, and in this case you can see on her arm, you see the elbow, the forearm, you can see 2 at her wrist, and then on her hand, if you just kind of move it around in the light, it'll reflect, and there's 4 visible red lights and 2 infrared lights, and so all that's really happening is the light is hitting the reflective ball, bouncing back to the camera, and then the camera tracks that. It sees that as a point, and it's able to see it move through space as it reflects the light. And then get ready in position, Yvonne. So now as she plays, there's a certain pattern that she'll have of motion. And different violinists will have motion in different ways. And if we compare different types of violinists, different people playing the same music in a controlled setting, we'd have the musicians playing exactly the same thing so that we can compare them. And they would likely have different movement patterns. One thing that a lot of people don't understand is that performing artists have an inordinate number of injuries. Dancers and instrumentalists both. Because of the repetition of their artistic forms, they have a tremendous problem with breakdown of the body and injuries that occur. And so what we're trying to do is look at the demands on the musculoskeletal system so that we're better able to help dancers and help instrumentalists with their technique to try to decrease the number of injuries that they experience. And that's all 6 cameras information. And you can see the different movement patterns, and again, the software will take all of that and format a stick figure that will allow us to then analyze the motion. So in this particular case, we'll put it on the hips, and we have specific anatomical locations of the bones. And so this is the front part of the pelvis right here. Here we have them on the kneecaps, we have them on the ankles. You can use as many markers as you want. The more you have, the more complicated it is. But the bottom line that we're looking for is known points. And if we can map these known points through space, then we're able to assemble a three-dimensional figure that's going to help us understand what the movement is and to see the movement patterns. Now we can put them on the instrument as well. But what we're really interested in is what's the human motion, what are the patterns of the person moving. So the way that the bow moves is going to depend on how the person moves. And it's how the person moves that becomes the issue, because when that person moves and does so in a way that might not be biomechanically as efficient, then that's when we can start seeing injuries crop up, because they repeat their activity over and over and over and over, and the body it breaks down when the injury pattern, or when the movement pattern, I should say, is asked to do that time and time again in an incorrect pattern. Certainly there are medical applications, and you know, as one who's been involved in healthcare for a long time, I'm interested in people not having injuries. That's a prime goal. But also just to understand how movement is carried out is very interesting. This has been widely applied in sports, it's applied in film, all kinds of disciplines, but not nearly as much in performing arts. Yet, performing artists have an enormous number of injuries, and so what we're trying to do is look at their movement patterns, just to understand the demands on the musculoskeletal system of their artistic craft. What we've done is I have to go through and I've got to tell it these are the pelvic points, and I've got to tell these are in the thigh and the knee, and I tell it what each point is, and once the first time I tell it what the points are, then the computer can track the points as they move. And so when the subject moves, then it's going to take all those points, and basically you'll see a stick figure. So, but that's how it's done. I have to the first time tell it what the points are, so it knows, and then it tracks them the rest of the way itself. So it's pretty fascinating. It's very powerful software. We can move this around, and we can get a top view. You know, we can increase the magnification if we need to. So now what you're looking at is down on the top of the pelvis. So these four represent the pelvis, and then on down the legs. And you can clearly see there was one out here at her toe, got back here at her heel. You see the middle part of the ankle, and then on up the leg, connecting up to the pelvis.